Hello, in this video we're going to answer the question of how do we find sides and angles of oblique triangles. An oblique triangle is any triangle with no right angle. Just a reminder for triangles, if we have three angles A, B, and C, their sides are opposite their angles. Well, one law that we can use for certain triangles is the law of sines. It says that sine A over A equals sine B over B equals sine C over C. These are the angles and these are their sides. All right, so we can use the law of sines whenever the following are given. If we have a triangle where we know a side angle angle or angle side angle, we can even use law of sines for side side angle, but we got to be careful with this one because we can have an ambiguous case. So let's see examples of these. All right, so let's say that we were given A is equal to 40, B is equal to 20, and A is equal to 2. Reminder that these are angles and this is a side. So if I draw this out, and please note whenever I'm drawing these things, these are not to scale. The angle 20 is much smaller than this angle right here. I can use this to solve for sides B and C. So let's start by solving for side B. By the law of sines, I know sine A over A equals sine B over B. So I can take the sine of 40 over the side of A, which is 2, and set that equal to the sine of 20 over side B. So once I cross multiply, I have B sine 40 equals 2 sine 20. Now I can just divide both sides by the sine of 40 to solve for B. What I'll end up with is B equals 1.0642. To find angle C, anytime you have two other angles, you can just subtract them from 180. So 180 minus that 40 plus 20. So that's 180 minus 60, so angle C is 120 degrees. And then we can use that to find the side C using the law of sines. And using the same process as before, I can find that side C is 2.695. This makes sense that side C would be the biggest side because it was across from the biggest angle, 120 degrees. So really, once you just find a little bit of the triangle, you can figure out the whole rest of it. For the rest of the examples, I'm just going to find like one side or one angle, and just know that you could go further. So in this next example, we have A is equal to 35, B is equal to 15, and C is equal to 5. Let's go ahead and draw this. All right, so now you can see that we were given a triangle with angle, side, angle. And let's solve this problem for side B. All right, so this time I wasn't given an angle with a side across from it that I know, but I can solve for this third side just by subtracting those from 180. So this is 130. Now I can set up that the sine of C over C is equal to the sine of B over B. Now I can use the exact same steps as last time to solve for side B and get that B is equal to about 1.69 just by cross multiplying and dividing. We can use the same steps again and eventually solve for side A to get that side A is about 3.74. And again, that's all just using the same steps that we showed in the previous example. All right, so let's set up this next example, side-side angle. So A is equal to 6, B is equal to 8, and angle A is equal to 35 degrees. All right, so anytime that you have side-side angle, you have to be careful, and I'll show you when you need to really watch your step. All right, so I can start this problem by finding angle B, because I know that the sine of 35 over 6 will equal the sine of B over 8. All right, so whenever I cross multiply this, I'm going to get 6 sine B is equal to 8 sine 35. And I can divide both sides by 6 to get that the sine of B must equal 0.7648. And this is where we have to stop and pause. So before you do an inverse sine, you have to look at this value. If it's greater than 1 or less than -1, there's no solution. And that's because sines max and min are 1 and -1 respectively. So to solve this, we go, okay, B is equal to the inverse sine of 0.7648. So angle B is equal to 49.88 degrees. Using that, we could figure out angle C by just, 180 minus these two angles, and so on and so forth to find all the sides. All right, so next up we have law of cosines. So take a second to write these down before I talk about them. All right, so what you might notice is that they're basically all the same equation, just written differently. If I'm solving for a squared, so this side squared, I'm going to use these two sides and the included angle. And that happens every single time for b squared. So for this side, I use a and c and angle b. So it's always the two sides and the included angle. And that helps us know when we can use law of cosines. We use law of cosines anytime we have side angle side, which is just two sides with an included angle, or side side side. So let's see those two cases. All right, so let's look at a side angle side case. Also, sorry I'm switching up my triangle so much. So I'm given that side B is equal to 4, side C is equal to 2, and angle A is equal to 30. So you can see my two sides with an included angle. So because I have angle A, I'm going to use this formula. Because I know B and C, and I know A. So really, this is just plugging numbers in. So I would just type all of this in, and then don't forget to take the square root because this is a squared, and I would find that A is equal to 2.47. And from this point, now I can use the law of sines, right? Because I'm back to a side-side angle. So basically, whenever you use the law of cosines, you only have to use it once, and then you can go back and find everything else using law of sines. The final case is for side, side, side. So here we have our triangle with the sides 4, 3, and 6, and I'm always going to suggest finding the largest angle first, and the largest angle is always across from the largest side. So I'm going to set up my equation. C squared is equal to A squared plus B squared, and so forth. So plug in all the numbers. All right, so now I've got this stuff. The first thing I'm going to do is subtract this 4 squared and 3 squared from 6 squared. All right, so what I end up with here is I have 11 is equal to, then multiply these things out, negative 24 cosine C. Divide both sides by negative 24. And I get that the cosine of C is equal to negative 0.458. So to solve for angle C, it's going to equal the inverse cosine of negative 0.458, which is 117.28 degrees. Now that I have this, again, I've got side angle side now. I've also got angle side side, so I can go back to using law of sines. All right, and so those are the laws of sines and cosines. Goodbye.